Okay, we'll wait for 2 more minutes. Then we can start.
Right. Below us. Much below us.
Okay, seems everybody enjoying their holiday today. Okay, fine. Let us start. So I'll just take a quick overview. So what we have discussed yesterday. So yesterday we started with a video with an to show the different kinds of hazards which we would have faced in our general life and work life. Then we started the history of electricity. Then we have seen some of the causes which leads to the electrical accidents. Then we have seen different types of accidents, hazards. So electric shock, burns and fire and explosion, lightning, etc. Then we have seen how these injuries will fall and what are the different types of productions we can bring in to avoid these accidents, like fuses, circuit breakers, earthing, bonding, etc. Then we have seen the statutory provisions from factories and the standards which are there for uh, guiding us to avoid such a kind of accidents, and also the procedures to be followed to avoid those kind of accidents. Then we have seen the amount of electricity which is required to lead to a fatal or any serious injury. Then we have taken example of an average person of 68 kilograms of man. So how much of current it will impact on him. So as we see in 75 and 30 milliamperes will stop the breathing. Then 75 milliamperes possibly it may fatal. Sometimes it depends on the how much time he's been in the circuit and how much amount of current which is passes through him. Then if we say 250 milliamperes, it is definitely a fatal case. Then a safe distance from the electrical lines. This already we covered in last study and the previous sessions as well. Then we have seen some of the general safety measures. Okay, then no load protection. And we have seen earthing standards, which is IS 3043, and we have SB30 as well. Then we have discussed about lockout and tagout. Yeah, somewhere in, I think, first point we have till this point we covered yesterday. Okay. Right. So again, when we say the procedure of a lockout should be established. So when I say a procedure, so it should be common for the entire industry, so that everybody follows the same manner. Otherwise, everybody will have their different knowledge and their experiences. They will apply those skills. So it is not like that. When we create a procedure, everybody should be abide to that. So before locking or tagging, inform the concerned operator and the users that line, switch, valve, or equipment will be isolated or de-energized, and give them time to complete or to stop their work. So when you are attending any activity on any specific equipment, or you are going to apply any lotto, such an equipment, so definitely we have to inform them. So we are taking over this machine for the shutdown or any immediate breakdown or any accidental breakdown or any regular PM. So we have to give some time to the operators so that they will be handling or they will be hand over a mission to the concerned maintenance team or a concerned third party if third party is involved. Then plan the shutdown and make them system off. So you will completely stop all the systems. Then insert lock and attach tagging. So wherever we have different types of energies, if it is chemical pipelines or in pneumatic pipelines, is there any hydraulic systems or an electrical energy, any other mechanical energy or any inverter which is connected to this equipment. So everything will be shutting off and will be applying locks to their switches so that nobody will be able to again turn on. Then test the isolation is positive and also so expression. Then when repair or maintenance work is over, open the lock and tagging and again inform the concerned people locking tagging is removed and they can work usually. So when repair is completed, again we have to inform to the people so that until otherwise we are not reporting them, because the locks may be in the maintenance area, in the panel room, or in the different location from the equipment area. Sometimes it will be close by, sometimes it will be far away from also. So again, it is the responsibility of the concerned person who has done the work. They have to inform back to the mission operators or equipment operators saying that the work is completed. Now it is ready to use. Then lightning arrestor. So when we say lightning arrestor, so it is also a very good conductor to take the energy which is released from the atmosphere. So when we say the purpose of a lightning arrestor is to attract the lightning from the sky and also bypass it to the ground and not allowing to pass through any combustible materials. It is not about attracting. We are not wantedly asking the lightning energy to pass through our building or through our lightning arrestor. It is about if it is the lightning is happen nearby, it may contact our building. So the lightning arrestor will safeguard us to take that high intensity of energy in a safer manner. It will discharge. So when we see if the lightning arrestor is not there, such high volt of energy, which is if it strikes the building, so there is a chance of igniting in case of any combustible materials, if it is any petroleum products or if it is any flammable chemicals which are there, it will have high chance to ignite those materials, resulting in fire accident. So basically, these are a pole type and a long rod of a good conductor is attached on the tallest structure at the site. So because of its good conductivity, low electrical resistance and electrical current of the lightning is directly passed into the earth. It is necessary to check its continuity and also resistance of the lightning arrestor at regular intervals. So it will be keeping at the tallest building in your facility so that it will have a nice coverage based on the different makes and different conditions. It will have its own radius so that within that radius it will protect the buildings from this energy discharge. So basically it is a very good conductor. They prefer aluminum and copper. Mostly they prefer copper strip as a good conductor. If it is if you go for a lower cost side, so aluminum will be used as a conductor for this lightning. Again, this lightning arrestor will be connected to the separate earth pit, and it is not going to be connected with any other earth pits to avoid impact on the other equipments, etc. Then electric work in hazardous atmosphere. Regarding the lightning arrestor, we have another presentation. We'll see some more details in that PPT. Okay. So when we come to the electric work, so as we discussed in our previous lectures, so zone 0, zone 1 and zone 2. So this is a zone classification based on the atmosphere or based on the type of environment which can create where we are going to install flame-proof electrical fittings. Even IS Indian standard also 5572 divides the hazardous area containing flammable gas or vapor and also capable to ignite into a following 3 zones of purpose to appropriate electrical installations. So once we classified based on this IS 5572 standard, so there we can go with suitable electrical installations. When I say zone 0, so here the hazardous atmosphere exists continuously, which means it will continuously present the hazardous atmosphere. I can say vapor cloud. For example, the vapor space of the closed pressure vessels or any storage tanks, closed containers, or any spark will certainly lead to a fire or any explosion. Therefore, any electrical apparatus in this zone must be afforded an absolute protection inside the tanks or inside the barrel. So these kind of situations are near the storage tanks, inside the store tank. When we say if it is in a big storage tank, if the lightning arrest is not there with the storage tank, in case of any lightning strikes that container or the tank, definitely there will be an explosion due to the high energy which is discharging from the atmosphere. Then zone 1, here the hazardous atmosphere is likely to exist at any time. Therefore, the fullest practically measure should be applied to prevent the hazardous electrical condition at any time and any circumstances. So this is a kind of zones at any time the atmosphere can happen here. So previously, if you say that is continuously present, but in zone 2, it is anytime it can happen. So they are in such a way that all our electrical appliances should be ready in such situations. It is not going to generate any spark or any heat. Then zone 2. So here are the hazardous atmosphere is likely to occur only under the abnormal operating conditions. So maybe any incident happens or any leakage happens. And this classification is applicable only for the fire and explosion hazard, is unlikely and may cause only by the simultaneous and also improbable occurrence of arc, spark resulting from the electrical failure and the hazardous atmosphere rising through the failure of conditions of the controls. Sometimes in case of any control failures happens also, this kind of atmosphere can create an issue. Excuse me. There are different types of protection. Generally, it is applicable in the electric motors for the use in hazardous area. So flame proof or explosion proof. These are type D, and increased safety. This is type E, and intrinsic safety type I, and non-sparking type N, and also pressurized type P. These are the different types of flame proof electrical equipments. Okay, if you see the flame proof, which is D, it can be used in zone 1 and 2. So the advantages will be robust permits, maintenance of internal equipment, and disadvantages will be expensive in the large sizes, difficulty to weather proof, careful maintenance. And even we can see more detail in IS 2148 and as well as 3682. Then increased safety, it comes with the symbol E, most suitable for zone 2. Zone 2 in the sense, there the hazardous atmosphere situation happens anytime, sorry. It means abnormal conditions. It is cheaper, suitable for all the gases and also long life. Wherever we see there is a chance of leakages, gas leakages happens. In such cases, we can use these type of electrical installations and equipment so that we can safeguard our premises. Required again careful installation here. For this also we have IS 6381 standard for more detail. Then non-sparking, which is also under zone 2, which is also cheap. Some design difficulties in maintenance, that is an advantage. Even we used to have non-sparking tools in production areas, and where if you're working on any pipelines where there is a chance of presence of that atmosphere, which will ignite in case of you're using such kind of tools or doing any hammering or any cutting, it will create a spark, leads to accidents. Then pressurized, which is P, which can be used in 1 and 2, where the atmosphere can create any time and also abnormal operations. Here also we have safe and suitable for all gases, can be modified and also maintained. Then auxiliary equipment needs to provide dry air and inert gas. Whatever the auxiliaries which is connected to these equipments, it should be provided with inert gas so that it is going to help the equipment in case of any short circuit or in case an overload happens. Still, it will not allow the spark which will come out of the all electrical installations. And for this, we have 7389, where we can get detailed information with respect to this pressurized type electrical fittings. Okay, with this, we have done this topic. I'll jump into the other topic, which is lightning arrestors. Meanwhile, if you have any question, you can answer.
Sir, this electrical fittings means even motors, main drives, all the things it will include, or just for breakers or switches, those things only it will be there.
Switches, even motors also will be covered in this. Wherever you are installing, for example, basically in the organization, they will do a zone classification. For example, if you see in a tank farm area, majorly what will have, where we have the switches and breakers and motors. These will be, what do you call, flame-proof electrical equipment. Based on the area classification, we'll install this.
Okay.
Yeah. I'm sharing my screen. Once you are able to see that, just say yes in chat box, please. Hope now it is visible.
Yes, visible, sir.
Yeah. So we have seen lightning arrestor. We'll try to understand how it happens, how the lightning happens. So when I say lightning, it is a discharge of high amount of electrical charge from the atmosphere. So basically, it is in a naturally occurring process. Nobody is generating, no human being is caused for that discharge. This is kind of electrostatic discharge during which two electrically charged regions like clouds, both in the atmosphere or with one in the ground. Sometimes what will happen within the clouds also, the discharge can happen. That we called as intercloud discharge. Sometimes it will happen between the clouds and the ground. So basically what will happen, electrical charge in both regions in the atmosphere or within one on the ground. So the ground in the sense either a direct ground or sometimes in the path, maybe a trees or sometimes maybe it will strike the buildings or the topmost structure where it will get the high neutral area. So temporarily it is just neutralizing themselves, causing the instantaneous release of an average of 1 gigajoule of energy. So this discharge may produce a wide range of electromagnetic radiation from the heat created by a rapid movement of electrons from the atmosphere to the ground. When brilliant flashes of visible light in from the black body radiation, the lightning causes thunder, a sound from the shock wave, which develops as a gases in the vicinity, and also discharge experience is a sudden increase in the pressure. Because of the sudden increase in the pressure, shock wave, we can hear that sound which is generated. The lightning occurs commonly during thunderstorms as well as other types of energetic weather systems, but the volcanic lightning can also occur during the volcanic eruption. So when the volcanoes erupting also, during that time also we can see a lightning effect. As I mentioned, the two types, one is inter-cloud. So if you see in the left side picture where it is happening, within the clouds, it is discharging from one cloud to the other cloud. If you see in the right side picture, which is discharging, it is happening from the cloud to the atmosphere, from the atmosphere to the earth surface. Either maybe it will strike on a building or any other tallest structure. There are three main kinds of lightning are distinguished by the how they occur. Either inside a single thundercloud, it is happening within the cloud, and between two different clouds, as I said, maybe it will happen in two different clouds which is nearby, or between a cloud and the ground, which is the second right side picture in the slide. When you say many other observational variants are recognized, which is including heat lightning, which can be seen from the great distance, but not here, but dry lightning, which can cause forest fires, and also ball lightning, which is clearly observed by the scientifically. So the ball lightning, it is not visibly seen, but it is scientifically, there is a different kind of lightning, which is a ball lightning. We see visibly even heat lightning and also dry lightning, we can usually observe during the rainy seasons. When we say the purpose of lighting, so if you can see these kind of fittings, this is a lightning arrestor installed in one of the building. It is commonly used in different locations, even substations, buildings, storage areas, high-rise buildings, even commercial, domestic buildings. Everywhere they will install this, and they will have separate conductor, and they will attach to a dedicated earth pit. So when we see a purpose of lightning arrestor, it is basically to attract the lightning from the sky and to bypass into the ground, do not allowing to pass any combustible material. Again, it is in a pole type of rod. A good conductor will be used to take that energy back to the ground. Again, it is not desirable to attach lightning arrestor directly on the metallic tank or any flammable liquid gas, because in case of any unknown disconnectivity, the lightning may pass through the metal surface and the whole tank may trap into the fire. So that's why we should have a separate path for taking this lightning energy to the ground. When we see in the lightning protection system, you can see in the picture, so the highest top of the building, it is striked. The lightning rod is a single component of the system, and the lightning rod requires a connection to the earth to perform its protective function. And lightning rod come to a main different forms, including hollow, solid, pointed, rounded, flat strip, and even single bristle brush-like. So it will be in a different form. It does not mean that it should be in only in a round in shape, only it is in flat in shape, or only it is in hollow, or only it is in a solid shape. It will have in a different types or in different forms. The main attribute common to all the lightning rods is that they are all made of conductive materials. When we say conductive materials, it will allow the electrons to move within one point to other point, such as copper, aluminum. And copper and its alloy are the most common materials used for the lightning arrestors. And even we could see sometimes aluminum will be more because it is cheaper than the copper, but copper will give the better protection than the aluminum. Then lightning protection system includes a network of air terminals and bonding conductors. So air terminals will be, which we have seen in the previous picture, and ground electrodes designed to provide in a low impedance path to the ground for potential strikes. The lightning protection system are used to prevent lightning strike damage to the structures. Because of low impedance, the difference between the ground, because in the lightning in the atmosphere will have high energy. Because of this low impedance, it will attract and directly it will discharge to the ground. So again, it is in a simple picture. So how it is happens. So there we have a positive and negative charges. So high amount of negative charge which is close by. It is just a process of neutralizing the energy which is generated due to the friction between the two different clouds, the water molecules and the icy crystals in the cloud and also the air. Due to that friction, there is a charge generation within the clouds. Whenever it is accumulates in higher and higher quantities, it will have a tendency to jump to neutralize. So Earth is an act as a highly positive charge. So to neutralize the high amount of negative charge which is generated, it will have tendency to jump. Within this process, we can see that the visible spark and also the high amount of energy which is coming from the atmosphere. Okay. So you can go through the technicalities which I have shown the standards for the more detail. For the course point of view, this is more than sufficient. Okay. With this, I'll just take you to the give an overview. With this, we have completed the IS 102 sessions. In this, we have covered safety while using the machines, ventilation, then ergonomics in the machine guarding. We have covered hand tools and portable power tools, industrial lighting and illumination, material handling. In that, we have covered manual metal handling and mechanical metal handling. Then we have covered noise and vibration, static electricity, work at height, electrical hazards, lightning arrestors, and also plant designing and housekeeping. Okay, so all other presentations I have shared. So whatever the presentation we used yesterday and today, I'll share today with this. Hopefully you will get all this PPTs. So I'll take you through the other topic, which is IS 103. Just give me a minute time. Hope my screen is visible. So when I say IS 103, it talks about different types of industrial processes and also what are the hazards associated in that process and also safety precautions which is supposed to be followed. So basically here we cover construction, even dock, textile, and when I say in agriculture, so there we commonly see take the sugarcane industry. Even we'll talk about the manufacturing of metal industries, like we'll cover in the hazards in the metal processing industries as well. Okay, let us start with the sugarcane industry, which is nothing but agriculture sector. We'll try to understand the production process and harvesting to the final product. So mostly you would have aware about how this sugarcane produced, then it will be go to the process plants, then it will be turned into a sugar. So first, the most point is the harvesting.
Sir, this is third chapter, na sir?
Yeah, this is the IS 103.
103.
Third
Today
paper.
onwards, sir. Third
Yeah,
paper.
from today onwards.
Okay.
लक्ष्मण जी, आप जो बोला था ना, आपको कुछ एक दो दिन प्रेजेंटेशन नहीं मिला करके, आप कुछ लिस्ट कर पाया वो?
हाँ सर.
हाँ हाँ, बता सकते हैं मेरे को कौन सी
नहीं
टॉपिक है?
sir, I will take sir from other person. Now I have no issue, sir.
ओके ओके फाइन, थैंक्स.
Yeah, my colleagues will
अभी
give
ऐसा
me.
होता ना, मेरे को
हाँ.
बताना, मैं फिर से शेयर करता हूँ.
Sure, sir.
ठीक है, थैंक यू. Okay, so the starting point of a sugar. So when we are having sugar, while having tea, coffee, or we use many applications. So sugar also becoming a part of our life. Sugar also is now it is becoming part in our body also. So most of them having early diabetes. So because of unhealthy eating habits, even at the age of 30, at the age of 25, at the age of 40, the people are affecting with sugar. So when we say sugar, it starts with harvesting. Happens in the farmlands. Sugarcane is harvested using the by the mechanical this thing harvesters and manually cut by the workers as well. Then harvested sugarcane is loaded to the trucks and transported to the processing facilities. Okay. So we'll see the basic steps. I think here we have less than a minute. I'll take only headings. Then it will go to the preparation and milling process. Then after that, we'll have juice extraction from the sugar cane. Then juice clarification. So to take out the impurities, etc. Okay. Then juice evaporation and concentration will have the crystallization and centrifugation, drying and cooling. These are the basic steps in processing of sugar. So after the break,